Page 94. Past year paper, have you got your past year paper?
对啊，
Okay. So basically, this is a summary lah, of the old syllabus is topic 4 lah, but topic 3 for your new syllabus lah. Okay, what's the answer for this one? Yep. What's the answer? An engine of an intercity train traveling at 50 meters per second delivers power of 2 meter per watt, 2 megawatts, sorry. What is the attractive force exerted by the engine? Why it take so long?
wait ah, let me solve it.
Using this formula, that's all. Can?
Yep. Wait.
The answer is A. How about this one? If P is the momentum of an object of mass M, the expression this one has a base unit, has identical base unit to
B square. Wait.
work it out lor. Same as kinetic energy formula. So energy lor. Okay now.
Yeah.
A ball of mass 0.2 kilogram is projected vertically upwards with a velocity of 20 meters per second. When it returns to its point of projection, its velocity is 50 meters per second downwards. Taking upwards as positive, what is the change in momentum of the ball during its flight? What's the answer? I have a picture of what is happening. Or draw it
I
out.
got 7 minus
So change in
minus 7
final momentum minus initial momentum. Yep, minus 7. So
H.
correct.
Yeah.
20. How about this one? A passenger stands in an ascending lift. Which statement about the force exerted by the floor on the passenger feet is always true?
Ascending means going up, right? So
Then it's going up.
greater B.
Now, ascending, it doesn't tell you whether it's accelerating or uniform velocity. So that's unclear there.
Oh,
Equal in magnitude to the weight of the passenger, no. False. This is true when the lift is stationary or moving at constant speed. Is greater than it would be in a stationary lift. False. The stationary lift weight equals normal reaction, no? Is equal to what would be in a stationary lift. False. Is true only for stationary lift, but not for accelerating lift. Is equal in magnitude to the force the passenger feet exert on the floor. This action and reaction, no? Newton's third law.
oh yeah, yeah. Okay,
Answer is
okay.
donkey, no? Right? Make sure you know how to work with lift. If it's accelerating upwards, then you use Newton's second law, N minus mg plus ma. Okay, that's how you calculate it. Okay, how about this one? Yep, can. You got slightly less than 2 minutes to do it. One question. E is a thrust. Mass is given. Acceleration is given. Friction is not given. So using Newton's second law, E minus F equals ma. Put in what is given. Calculate out. Can.
E is thrust, right?
E is thrust or applied force. Okay now.
Yeah, okay. Yeah.
What is meant by the weight on an object?
Either B or C.
Must be sure there's only one answer only. B. Weight is a force. Its presence is because the mass is in a gravitational field. Okay,
Wait, teacher, why is it not C? Mass times gravitational
that's how
acceleration.
we calculate. It's the mass in the gravitational field. Okay,
Okay.
how about this one? Speed it out. X, mass M, acceleration A, Fy, and Fx. Split into block X and block Y. Y is 3m. It's given here. X is m. So use Newton's second law. Resultant force is ma. Right? Look at the total block with the applied force. Find the acceleration. Acceleration is the same in this case, or in this case, or in this case. It's the same. So calculate the acceleration first. Right? F equals 4ma for this part. A is F over 4m. And this one is Y on X. Y acting on X. There's this force there. Is X, force of X acting on Y. Action and reaction force is 2. Okay, both are action and reaction force, Fx and Fy. Then you look at Fx. Right? Fx is Fx is part acting on 3m. So 3m times A. A is we have calculated out there. Put inside there. You get 3f over 4. Okay, can.
Okay.
How about this one? A car with a front wheel drive accelerates in the direction shown. Which diagram best show the direction of the total force exerted by the road on the front wheel?
I think it's A.
No, total reaction force, not only the reaction, normal reaction.
Oh, let's B.
Right? The car is moving this way, so the frictional force is going this way. Reaction force, frictional force. Then there's a normal reaction. So the total force is the two together. The answer is B. Can
Yeah.
which is not Newton's law of motion. Yep, it should know all this by heart. Answer A lor. Conservation of momentum is a consequence of Newton's second law of motion and Newton's third law of motion. Can
Oh,
this second law of motion, this third law of motion, Newton's third law of motion, this is the first law of motion. Okay,
how about A?
answer is A lor. A is a result of second law and third law. It's not Newton's law.
Oh, okay.
It must be clear what is Newton's law. This is the second law. This is the third law. This is the first law. Right? That's my abbreviation, Newton's second law of motion. How about this one? Yep. Why it take so long? This is like your velocity time graph. The velocity time graph is based.
Uptrust.
Yeah, what is the answer?
I think it's a wait, C or C.
No? A. There's your weight going down. There's your friction going up. Opposite direction. A. Air resistance increases with time. With time as speed of the ball. Right? It follows the same as this air resistance follow as the speed with time. Same thing. Right? This is like acceleration. The acceleration is the resultant force. So, yep. Anything not
Oh,
clear?
okay.
Acceleration is going
Yeah.
zero. So it's like the resultant force. So, how about this one? An object is dropped from a great height and falls through air of uniform density. Acceleration of free fall is g, which graph shows variation with time t of the acceleration a of the object.
I think it's either B or A.
One,
B or D.
same as this one. Right? Initially is g, you drop it, initial acceleration is g. Great height means air resistance is significant. So it will decrease to zero. At terminal velocity will be zero.
Oh,
Okay now. Stop me if I'm
yeah.
going fast. A ball falls vertically and bounces on the ground. The following statements are about forces acting while the ball is in contact with the ground. Which statement is correct? This one is the same as the lift that we just did.
I think it's B.
Donkey, correct? Sorry, B. Sorry, not donkey. B. The force that the
Ah,
ball
boy.
exerts on the ground is always equal in magnitude and opposite in direction to the force the ground exerts on the ball. This is your Newton's third law of motion. How about this one? Yep. But 10 is in the original paper. 16 is my numbering. Yep. Average force, change in momentum over time. Change in momentum is final minus initial. Time is t2 minus t1. So final one is p2. Initial one is p1. t2 minus t1. The answer is B. We are not interested in direction. So we don't have to worry about negative sign. Okay or not?
Yeah.
How about this one? Yep.
I think it's A.
A. This is the height. This is the time. Terminal velocity. We are told is falling at terminal velocity. So the for velocity time graph. Sorry, for height time graph. The gradient is the velocity. Good. Let's try something else. How about this one? What is the magnitude of the change in momentum?
Uh, 5,000 D. Wait, wait, wait. No, wait. 是 wait, wait. 5,000 D. 5,000 D. Wait, wait, wait. No, wait. 是 wait, 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 wait. 是
You have to choose the one direction as positive, lor.
Oh,
Okay.
yeah. It's B, it's
So
B,
this
it's
is
B.
minus 30, lor. So change in momentum is final minus initial. So change to kilogram, this one, 100 gram.
Boy.
Answer is boy, lor. As I say, we are not worried about negative sign. Negative sign show direction only. You want magnitude. How about this one? A stone is projected horizontally in vacuum and move along the path shown. X is a point on this path. X, XV, and XH are vertical and horizontal lines respectively through X. XT, XT is a tangent to the path at X, along which direction do forces act on the stone at X. Yep. No air resistant in vacuum. So which forces got
Vacuum. So it's just XV,
XV, lor.
XV. Yeah, because it's vacuum.
You're told in vacuum, so it's XV, lor. Okay, let's try something else. Distinguish between mass of a body and its weight. What is mass?
Uh,
Right? Measure of the body's resistance, inertia to change in velocity. Some years they accept quantity of matter, but better not. Measure of the body's resistance to motion. That's the best one.
oh, okay.
Eight.
Product of mass and
No, effect of gravitational field on the
gravitational.
mass of gravitation, force of gravity. Okay.
Okay.
Other answer they accept. Further comment example, mass is constant, weight varies equals to m weight equals mg, scalar and vector quantity. Some years they may not accept it.
Yeah.
State two situation where the body of constant mass may experience a change in its apparent weight.
Uh, change. Oh, wait. Like I could say, like different planet, different gravitational acceleration.
Where is the situation? Where gravitational field changes, your g changes because your weight is mg. So wherever the g changes, change in field
You can say
surrounding the
different
body,
planet, right?
change in field surrounding the body, apparent weight. Okay.
Yeah, you can say different planet, right?
Say again,
Different planet.
change if it's in different planet or different mass. That's where the gravitational field changes. Different planet have different gravitational field. Okay.
Yeah.
A ball falls from rest on a flat surface, figure 3.1 shows the variation with time t of the velocity of the ball as it approaches and rebounds from the surface. So you must understand this one, it dropped the ball, this part it reached at the maximum point, it reached the plate, the flat horizontal surface, and then this one is being, the ball is being squeezed, it's completely squeezed completely, and this one is regained its shape back, and then this one is moving up, right? It's coming down, it's moving up. Use your data on figure 3.1 to determine the distance traveled by the ball during the first 0.4 second. How do you do that?
Area.
How do you do that? How do you find the
Area
distance?
of triangle.
Area of triangle. It's like area of triangle. So you're working, right? It's 0.4, and this one is 4, so 0.8. Change in momentum of the ball or mass 45 gram during the contact with the surface. Right? Go and read from the graph. Right? Coming down, positive 4.2 at this maximum height, 4.2. And at this one, minus 3.6. Right? Change in momentum, make sure you know how to calculate and put in your value. Right? Don't worry about negative sign. Usually you don't bother about negative sign. It just shows direction only. Shows that the change is opposite to the initial direction. We take downwards as positive. Okay, not?
Yeah.
Average force acting on the ball during the contact time with the surface. How to calculate that? There's a contact time from here.
Because MV square.
Right? There's a contact time from 0.2, 0.4 second to 5.7 second. Or 10 more minutes. Right? So there's a change in time. Right? They give you a range lah. Right? And change in momentum of a change in time. 2.5 Newton. Okay. Any comment?
Yeah.
Clear?
No.
Number 65. A sphere of radius r is moving through a fluid with constant speed. There is frictional force F acting on the sphere, which is given by 6 pi d r v. D depends on the fluid. Show that the SI base unit of D is that. I should be able to do that. Subject your V, your D, and then the unit of force. Unit of force, R is in meter, V is meter per second. Then simplify, meter cancel. S, you still got S minus 1 kilogram. You got 1 meter, minus 1. Can
Yeah.
a raindrop of radius 1.5 millimeter falls vertically in air at a velocity of 3.7 meter per second. The value of D in air is given. Density of water is given. Calculate the magnitude of the frictional force. They give you the formula, they expect you to use the formula. Right? Have a picture what is happening in your mind. If you don't, to draw it out. Right? That's your frictional force. Put in your value. Right? D is given there. That's your D. R, change it to meter. V, 3.7.
Yeah.
Acceleration of the raindrop. How to calculate acceleration of the raindrop? Mass is not given. So how to calculate?
F equals MA.
F equals to ma, yeah? How to calculate? There's your picture. F already calculate. mg minus F equals
Yeah,
m.
then it's
But you haven't got mass. How to
yeah.
calculate mass? Right? That's how you calculate your mass. So density times volume.
Oh,
Density is given. Sorted by R cube. Right? mg minus F is ma. Then subtract A divided by m. So m, put in your value. 9.81 here. F is you calculate F divided by, there's a mass. Okay.
yeah.
Variation with time t of velocity of the raindrop as shown in figure 2.1. State the variation with time of the acceleration of the raindrop. Yep. How does the acceleration changes? Must tell the examiner how you read from the graph. Acceleration.
Acceleration decreases.
I think this is 4 mark. 3 or 4 mark. You have to give more than that. Simply you must give your reasoning step by step. First step,
Decreases due to like
A equals
because
to
it hits terminal velocity.
at time t equals 0. Right? A, how do we read A from the graph? Gradient of tangent to the curve. A decreases as time increases. A goes to 0 when the raindrop reaches move with terminal velocity. Step by step, your reasoning. Okay,
Yeah.
Oh, sorry. A second raindrop has a radius that is smaller than that given in A. On figure 2.1, sketch the variation of speed with time of the second raindrop. How should we draw? Go back to the physics involved. At terminal velocity, friction equals to mg. Right? M is your rho, sorted by r cube. G, r and r cancel. So we can see from here, terminal velocity depend on r. So the smaller radius, the terminal velocity is smaller. That's important. Okay, so how do we sketch? There. Okay, now.
Yeah.
Conservation of momentum. In all collision, momentum is conserved. In elastic collision and adhesion condition, kinetic energy is conserved. Don't use the word conserve lah. You should use kinetic energy initially equals kinetic energy finally. Or relative velocity of approach equals relative velocity of separation. Don't know what your teacher teach you. Easiest is if you go together, you add them up. If they go opposite direction, you add them up. That's all. And remember, it's a vector quantity. Know how to write the equation down for conservation of momentum, for conservation of kinetic energy, if it's elastic collision. So if direction changes from that given, then you put negative sign on. Like in this case, right? This one is opposite direction. That's why we change to minus u. This one is supposed to go the other way. So we change to negative. This one is in the right direction. So correct. Can?
Yeah.
How about answer for this one? A body of mass m traveling at speed 5u collide with a stick with a body of mass 5m traveling in the same direction with a speed u. What is the speed with which the two bodies after sticking together? Right, anytime will be cut off already. Yep.
Oh, wait ah.
Can?
Mm.
This one? What's the answer? There's your pattern. Okay or not?
Yeah.